This is 16.7. Again, we're doing another one of these flux questions. This one's number 8, and it's very similar to the previous problem. Okay, we've got our vector field. We've got our surface that we want to evaluate through. So what I want to do is parameterize that. So we're going to use the easy one. R of uv is equal to u for x, v for y, and then the z component is just going to be u plus v squared plus 2. And again, the nice thing about that is now I know the u limits and the v limits, and of course the v limits include u, so I'm going to have to make sure I do the v integral first. Okay, well, let's evaluate our u, which is 1, 0, and 1, and our v is going to be 0, 1, and 2v. And now we need the cross product, our u crossed with our v, and the ith component is going to be -1, the jth component is going to be -2v, and the kth component is going to be 1. Oriented up, we check the z component. It is, so we're in good shape. That means it's measuring this vector field's passage through this surface in the upward direction, and that's exactly the way the surface is oriented. So position-wise, we're in good shape. Okay, well, we've got to convert our function f into these parameters. So this is a bit of a pain. We've got x, y, which is uv. We've got yz, which is v times all of this, so it's vu plus v cubed plus 2v, and then xz, so that's u times all of this, so that's u squared plus uv squared plus 2u. So there it is. That's the new f, and again, this is just written so that it's parameterized, and then I want to dot this with my n dot d or nds vector. So -1, -2v, and 1. Okay, so the dot product with this is -1 times this, so it's -uv. It's -2v times all of this middle part, so that is -2v squared u, -2v to the 4th, and -4v squared, and then 1 times all this, plus u squared plus uv squared plus 2u. So there's the dot product that makes up the argument, and then I just need to double integrate this. I've got to do v first, so dv du, and the v limits are from u to 1, and the v limits are from 0 to 1, and the u limits are from 0 to 1, the v limits are from u to 1. So there it is. It's a big mess, but again, none of the individual parts of the integral are challenging. It's just lots of minding. At least the upper limits are 1. When you're all done with this bad boy, you get -137 over 120. And what does that mean that the flux is negative? Well, we were looking at how it went through this surface oriented upward, and it turns out the vector field is fundamentally directed downward at that point. So what that means, and you can see a lot of that came as a result of the dotting, is we got a lot of negatives in here. So what that means is that the net field actually points in the opposite direction from the orientation of our surface. So more of the field is going backwards through it than forwards through it, and that's why I ended up with a negative result for evaluating the flux.